Before a Boeing jet ever takes off, it undergoes a test so violent it should destroy the plane entirely. Engineers bend the wings until they literally snap, and that's just one mind-blowing step in how these giants are built. Stick around until the end to see the final stress test, because it looks like a complete engineering nightmare. Boeing's 787 Dreamliner final assembly line is located in North Charleston, South Carolina. A Kuka Genesis robotic arm performs a detailed application process on a large composite panel. A Kuka robot's end effector unit is used to manipulate specialized tooling for precise positioning. A wing component is being moved by overhead cranes within the expansive production facility. Trailing edge wing flap component is precisely aligned and lowered using heavy chain rigging. Completed vertical stabilizer of the aircraft is prominent as the fuselage moves down the line. An Airbus wide-body fuselage is maneuvering towards the open doors of the structural test facility. A worker adjusts a safety railing near the fuselage of an aircraft undergoing structural testing. Specialized gantry system surrounds the aircraft fuselage, holding the wing test apparatus. At this point, the aircraft's forward fuselage is positioned vertically inside the tall metal structural test rig. Technicians attach numerous control cables and sensors to the lower wing structure of the plane. Underside of the wing assembly is covered with the metal plates used for mechanical load application. Hydraulic actuators apply precise computer-controlled loads for FAA certification, ensuring aircraft structural integrity and safety. A test controller monitors the structure through a window and reviews data on multiple screens. An internal view of the fuselage shows the frame structure with red staging used to mount equipment. Fuselage test article undergoes computerized structural load testing for vital FAA safety certification. A video feed displays the view of the aircraft wing and the surrounding test structure from above the fuselage. A computer-controlled hydraulic rig applies extreme flight simulating loads to a wing test article. Segmented spars and ribs of the wing structure are visible as they undergo tensile loading in the test. 787 Dreamliner wings use carbon composites and rake tips for maximum aerodynamic efficiency and fuel economy. It has optimized fuel efficiency and passenger comfort through advanced composite airframe construction. Its Trent 1000 engines cut fuel consumption by 20%, while its composite fuselage also enables higher cabin humidity. Boeing 787 Dreamliners fly 248 to 336 passengers. Airbus A380's sole final assembly line is the Toulouse facility, integrating massive European-built sections. Automated assembly jigs and logistic systems position massive composite fuselage sections for final integration. Multi-part A380 wings are precisely joined to the central fuselage section using engineered assembly tooling and processes. A technician manually positions a critical wing fuselage structural connector during final A380 wing marriage. Workers install acoustic insulation panels inside Airbus A380 fuselage to dampen cabin noise and vibrations. Technician uses artificial light for detailed quality inspection of internal aircraft components and installations. Workers reach the stage of the assembly where the overhead storage of the plane is installed. Airbus A380 seat installation tailors a flying hotel with precisely engineered airline-branded passenger experiences. Luxury passenger seats with extensive customization offer first-class levels of comfort and personal space. Workers remove protective covers from Asiana Airline-branded A380 cabin interiors for final delivery preparation. A specialized robotic cell operates a complex head-to-apply fiber composite material onto a fuselage section. Quality assurance spin testing validates jet engine fan assembly structural integrity and aerodynamic performance. Automated fiber placement machines use robotics to accurately lay composite fiber tapes onto a mold. Technician inspects jet engine core components for precision quality assurance before integration. Technician prepare jet engine core, connecting instrumentation for crucial performance testing and verification. Technicians conduct a final precision inspection on a Rolls-Royce Trent XWB turbine assembly. Technicians integrate and verify engine sensor wiring and diagnostics before testing. Technicians integrate the FATIC control system and verify critical engine sensor wiring. Specialized container transports a Trent XWB fan case, a vital supply chain link with critical handling instructions. Engineers employ a specialized handling fixture to precisely guide jet engine components for assembly. They align the major engine core and turbine module with precision for its subassembly.